So in this video, we are looking at decision tree algorithms, ID3 and CART across different data sets. And for the scope of this video, we're going to focus on a subset of the data sets for this assignment. So just to generally show how this program works, I prompt the user to choose a data set. So for a classification, I'll just choose car evaluation. And a lot of trees are going to print out. I'm going to do stratified cross-validation for when the tree is not pruned and when the tree is pruned. And then I'll just kind of show this what's going on for a regression one. So for regression, let's look at computer hardware with the CART algorithm. And for the same thing, I'm printing out the learned trees. I'm iterating early stopping based on some increased threshold, and I'm printing the output. But let's dive a little bit deeper. So let's just store the output in a temporary file just so we can look at it easier. And I'm gonna choose the car evaluation data set, and we'll see right in a sec when we open it that the car evaluation data set was chosen. This is our learned tree. So in ID3, we choose the attribute that provides the most information gain according to the gain ratio criterion. And we take that attribute and we turn into decision node and then remove it, right? So we're not going to see it again as we go down the tree. And I wonder what the average error with no pruning was, just under 7%, which is pretty well. And here, when I do pruning, just to kind of show that pruning's actually happening, I'm showing that, for, in this case, it's the first decision tree in my stratified cross-validation. I'm pruning at depth 4. It looks like the validation set had only one observation in it. And if I, did the non-pruned version, it would have been classified incorrectly versus the pruned, which is classified correctly. So in this case, I'm turning my decision node into a leaf node where the most frequent class, in this case, is going to return 1, which is encoded. Now, if I look at the average error, though, for this one, the average error was worse. But I do want to show that, for some, the average error does improve. So for the image segmentation, let's take a look at that. So I'm going to put in a temp file again. I'm going to choose 3 for image segmentation. We're going to open this up again, and I'll just search for average error. So with no pruning, the average error for image segmentation was 20.3%, but pruning actually improved the error in ID3 for image segmentation when it dropped to 17.6%. Not a big drop in the average error, but big enough that I wanted to show it in this video. So now let's look at a regression problem. For this, I want to focus on the red wine data set. So I'm just going to show again. I'm going to choose 7. So I'll store it in a temp file. And we're going to see the stratified cross-validation, the learned trees, and how we're doing the early stopping. So this is actually taking a bit to train and run too. So in the meantime, the video will be paused here. So I fast forwarded the video a little bit. The training took roughly 2+ minutes, but it was worth it. So let's open up the temp.txt. We're just going to scroll to the top. We looked at the red wine data set. So this is just the red, not the white wines. And as you'll see here, I'm going to increment on the early stopping. But let me just do a search on the early stopping. So as you'll see, the average error with no early stopping, 60.1. And this is my learned tree. As we go up of the early stopping, the average error decreases, which is good. This is the mean squared error. And our best value is going to end up being around 45.7%, which is great. Oh, 0.457. One thing to note also, with my implementation of CART, I'm not removing an attribute like in ID3 after I use it. Instead, what I'm doing is when I look at all the possible attributes that can be used for a decision node, I look at all the possible split values, and essentially I choose the best attribute and split.